Today we're on pages 56 and 57, inverse functions. When we talk about inverse functions, they are functions that undo each other. In exercise number 1, we want to consider the two linear functions given by the formulas f of x and g of x. We want to calculate f of 5 and g of 11, and we have a few calculations to do here. So I'm going to take the calculator and type in our two functions. F of x I'll type into y1, so alpha y equals, to get a fraction, 3x plus 7 over 2, and g of x is alpha y equals 2x minus 7 divided by 3. And now I'll just hit second graph, so I have my table of values up here. This way I don't have to keep showing the substitutions. Alright, so f of 5. F of 5 is going to equal, from the calculator, let's see, f of 5 is 11. And now what is g of 11? G of 11 actually, I'm going to change this to red, right, because my g of x function is in y2, which is in red. So g of 11 is equal to 5. Calculate f of 0. I'll switch to blue. F of 0 equals 7/2, and calculate g of 7/2. Well, it's not going to let me. 7/2 is 3.5. It's equivalent to 3.5, right? So we have to be midway between -1/3 and +1/3, which is 0. Alright, so the other way of doing that is if I change my table, so second window, table set, and instead of going by ones, I could go by a half, 0.5. I change that to 0.5, and then go back to the table. Now I have g of 3.5, right? 7/2 is equivalent to 3.5 is 0. Calculate f of g of -1. Okay, so in this case, stay there. We skipped over this type of question in Unit 1. It was Lesson 9, but I can easily show you that what you do is, it's like this is a nested parentheses. So we do inside this parenthesis first. So we're doing inside this parenthesis. And then inside this parenthesis, we have g of -1. Well, what is g of -1 equal to? G of -1, looking at my calculator, g of -1 is -3, right? This is the g of x function, equals -3. And now we do f of that result. So g of -1 in our parentheses there is -3. So bring down the f. So now we want f of -3, which is -1. D, we want g of 5. This is f of g of 5, so we do g of 5 equals 1, and f of 1 is equal to 5. So now, without a calculator, what do you think f of g of pi is going to equal? Go back here, f of g of -1 was equal to -1. In D, f of g of 5 was equal to 5. And now here in E, f of g of pi is going to equal pi. The two functions seen in exercise 1 are inverses because they literally undo one another. The general idea of inverses, f of x and g of x, is shown in the mapping diagram. So we have the domain of f maps to the range of f, but that range of f happens to be the domain of g, which maps to the range of g, which is the domain of f. Very confusing. In other words, the domain and range switch with inverses. Domain and range switch for inverses, for inverse functions. If the point negative 3, 5 lies on the graph of y equals f of x, then which of the following points must lie on the graph of its inverse? So we have the point negative 3, 5 is in the graph of f of x. So its inverse the domain and range switch domain is your x's, range is your y's, so these just switches. These switch. Negative 3, 5, they switch. 5, negative 3. Lies on graph of inverse. 5, negative 3. Choice 3. A function will have an inverse that is also a function if and only if it's one-to-one. A quick way to know it is a function has an inverse that is also a function is to apply the horizontal line test. Inverse functions have their own special notation as follows. If we have the function y equals f of x, its inverse is represented by this. It looks like a exponent of negative 1, but we read this as two ways of reading it. I'll say f of x inverse is the way it's read. Or f inverse of x. The best way is f of x inverse. Number exercise 3, the linear function f of x equals 2/3 x minus 2 is graphed below. Use a graph to answer the following. On the same set of axes, draw the graph of f of x inverse. Okay, so what I would do is just simply, if we want an inverse, let's take a few of these points and switch their coordinates. Right? Switch x and y's. Alright, so let me put down, let's see. So this point here has coordinates. This point here is 3, 0. This point here is 6, 2. And I'll take this point here, 0, negative 2. Right. So I'm going to take those 3 points, and for the inverse, I'm going to switch. So 6, 2 is going to switch to 2, 6. 3, 0, 0, 3. And 0, negative 2, negative 2, 0. And I'll plot those points. So 2, 6. 2, 6, 0, 3, and negative 2, 0. Okay, now let's label this once we connect these points. This is f of x inverse. Evaluate f of 2 inverse. So f of 2 inverse, so if I'm looking at my green line, an input of 2 has an output of what? As the output of 6. And f of 4, f of negative 4 inverse. So my green line, let's see, an input of negative 4 has an output of negative 3. Determine the y-intercept of f of x inverse. The y-intercept is right here. It is 3. Write the equation. Okay, so our equation is, our y-intercept is 3. What's our slope? And from this point to this point, we go up 1, 2, 3 and run over 2. That's 3 over 2 is our slope. So our equation would be f of x inverse is equal to equals mx plus b. I said our slope was 3 over 2 and our y-intercept was 3. So 3 halves x plus 3. Exercise 4, a table of values. For the simple quadratic function, f of x equals x squared is given below along with its graph. Alright, so here we have a graph, table of values, yep, negative 2, 4, okay. So this is f of x equals x squared. Graph the inverse by switching the ordered pairs. Again, so for inverse, we're just switching. So these x's now become this is the domain, now becomes the range here. So that's negative 2, negative 1, 0, 1, 2. And these outputs are now the inputs in our inverse function. 4, 1, 0, 1, 4. Okay. For f of x equals x squared, okay, the x's are our domain, and f of x is our range. So for the inverse, the domain of f of x now goes to the range of f of x inverse, and the range of f of x becomes the domain. Okay, so now plotting these points, go back to green, 4, negative 2, 1, negative 1, 0, 0, 1, 1, and 4, 2. We get this parabola that seems to be lying down on its side. What do we notice about the graph of its function's inverse? It is not a function. Right, the inverse is not a function. And f of x equals x squared is a function, but not a one-to-one function. Therefore, its inverse is not a function. 3 dots in the form of a triangle stands for therefore. Therefore, its inverse is not a function. Okay, so just remember when you are working with inverses or inverse functions, you switch the domain and range. And I thank you for your attention.